Hello students, welcome back to our video again. So today we are just continuing the coordinate geometry of optional math class 10 exercise 8.1 page number 168. So we are just continuing the short questions we yesterday we did up to 9, yes, 9 number, no, 8 number. We completed up to the number 8. Now today we'll be discussing about the 9 number and 10 number. So if the time remains, then we'll be doing furthermore other numbers also other question numbers also. For now, let's move on to the number 9. Find the equation of the altitude AD. So find the equation of altitude. The altitude means the perpendicular height. The altitude or the height must be always perpendicular to the base. So you know this the situation of perpendicular cases. So we'll be discussing about that. Okay, here this is just like we did in the past in past videos. Okay, so you can see here the idea to get the equation of altitude AD. Okay, the line BC is given here, and we have to find the equation of line AD, which is perpendicular to the line BC. Okay, and ABC being the points of the vertices of triangle. So the vertices of triangle is given here. So find the equation of altitude AD of triangle ABC with vertices A is given 2, 3, B minus 4, 1 and C 2, 0. Draw from the vertex A. From the vertex A, the altitude is drawn, which is perpendicular to BC. AD is the height of triangle ABC, so AD must be perpendicular to the base. So in that case, first the idea here we want to get is, first you get the equation of BC. Then after getting the equation of BC, the equation of line perpendicular to BC is given by, you know what to suppose, and since the line passes through a point 2, 3, you will get the value of K from there, and you just replace the value of K, you will get the required equation of line AD. So first find the equation of line BC. Here, equation of line BC is given by, so if 2 points are given, then you use the formula y minus y1 is equals to y2 minus y1 divided by x2 minus x1 x minus x1. So this is the formula. So you consider B x1 y1 and this x2 y2. So let's this be x1 y1 for your convenient. This be x2 y2, and you just replace the value here. Y minus y1 we have there 1, y2 this is 0, yes, 0, 0 minus y1 we have 1, x2 we have 2, 2 minus x1 we have minus 4, and here x minus x1 we have minus 4. Now simplify this, you get the equation of line BC. Y minus 1 is equals to minus 1 divided by 2 plus 4 x plus 4, or y minus 1 is equals to minus 1 by 4 plus 2 6, and another x plus 4, or now multiply 6 to the other side. 6y minus 6 is equals to minus, multiply this, minus x minus 4. Now move all to the left hand side. X plus 6y minus 6 plus 4 equals to 0, or x plus 6y, yes, minus 2 is equals to 0 is the equation of line BC. Now the equation of line perpendicular to line BC is given by you know this, how to do that. So equation of line BC is this. So you just write here the coefficient of x and y get interchanged. 6 will be here and 1 will be here, so no need to write. This plus becomes minus, plus there will be constant k is equals to 0. Let this be I. And this equation and this line passes through point 2, 3. Since line I passes through point A to 3, then what we can write is just substitute the value of x and y. Y we have 3 plus k equals to 0. 6 to the 12 minus 3 plus k equals to 0, which is 12 minus 3, 9, or k equals to minus 9. Now substitute the value of k in equation I, you will get the required equation of line AD. Therefore, so a little bit of space here, so I'm going to use this. Therefore, the required REQUIRED. Therefore, the required equation of line is just substitute the value of line AD. Required equation of line. Let's specify this. Line AD is 6x minus y. Just replace the value of k by minus 9. Minus 9 equals to 0, which is the required equation of line AD or altitude AD. This is how it is done. Okay. Now, after this, let's move on to the number 10. Okay. Without any further delay, let's move on to the number 10. Okay. So I'm going to rub this. So in number 10, you can see if the angle between the lines a square minus b square x minus p plus q y, this line and another line p square minus q square x plus a plus p y, there are two lines given, this and this. Okay, if the angles between these two lines is 90 degree means these two lines are perpendicular to each other. It means you use the perpendicular condition for perpendicular, that is the slope of this line and this line, when they product, when multiplied, their product must be equals to minus 1. So we use that condition there. So first you have to find the slope of this line. Let the slope of this line be, let the slope of this first line be m1, which is minus coefficient of x divided by coefficient of y. So minus coefficient of x coefficient we have a square minus b square, and coefficient of y we have minus p plus q. Okay, so minus minus cancelled, a square minus b square and p plus q. So this is the slope for line I. In the same way, let's move on to the another equation, the line double I. So let m2 be the let m2 be the slope of the line II. So same formula, minus coefficient of x divided by coefficient of y, which is minus coefficient of x p square minus q square divided by a plus b. Yes, here m1 we have a square minus b square p plus q. Here m2 we have minus p square minus q square divided by a plus b. So you can, if you want to make this positive, p square minus q square can be written as q square minus p square. Okay, and this minus sign will get positive there. So a plus b. Okay, now you can just, since the lines between them is 90 degree, angles between them is 90 degree, which means since the line are, that is double I and double I are perpendicular to each other. 90 degree means perpendicular to each other. Their product of their slopes, which is m1 is equals to m2, must be minus 1. So m1 we have a square minus b square divided by p plus q, and m2 we have q square minus p square divided by a plus b. So from the denominator side, okay, from the denominator side, no need to do anything here, but numerator can be changed into formula. A square minus b square can be written as a plus b, a minus b divided by p plus q, and q square minus p square can be written as q plus p, q minus p divided by a plus b is equals to minus 1. Now you can cut this like terms here. Like terms are the same terms. So a plus b, you can cancel that. Q plus p and p plus q, you can cancel that. Now the remaining you can write a minus b and another q minus p is equals to minus 1. But we have to prove this. A minus b, p minus q is equals to 1. Now a minus b, this q minus p can be written as p minus q. Okay, and this minus sign will get positive. Okay, or if you don't understand this, let's put it this way. This is a minus b. Now q minus p can be written as p minus q, but you have to change the sign here. This p minus q, the sign here becomes negative. Here is positive. After changing this, interchanging this place, there will be negative side, and this negative sign will get cancelled, and the remaining becomes a minus b, p minus q is equals to 1, which is we have to prove. Finished. Okay, so this much for today. Okay, for today's video. Okay, so this much for today's video. By completing this, we have finished the short questions of what we call that, short questions of the angles between any two lines, exercise 8.1 Vedanta Axle. So if you like my video, don't forget to like, subscribe and share to your friends. They might find this useful. Okay, so by saying this, I would like to end this video here. Take care, goodbye, and stay blessed.